All right, greetings, YouTube. Beautiful mind here. We have the following question that comes in from College Algebra. This comes from section 1.3, question 45 from the back of that section. This question says to perform the indicated operation and write the results in standard form. Okay, so this is about complex numbers. All right, so let's do. I usually like to write on grade paper; it just helps me. All right, so let's start by getting a copy of the original. So we'll start with this negative 24 plus the square root of negative 72 divided by 72, right? So it's something like this. The first thing that I do is I address this negative inside the radical first, right? We have a negative inside the radical. We want to address this guy first. So we can rewrite this radical in the following way. This is actually the same as negative 24 plus the square root of negative 1 times the square root of 72. Then we're going to say divided by 72, right? So now this square root of negative 1 in complex numbers, the whole reason for complex numbers is we introduce this imaginary number I so that the square root of negative 1 becomes I, right? So now we have, we don't, in the real numbering system, that's a number that doesn't exist. So in mathematics, when something doesn't exist, you just create it, you give it a name, and you keep it moving. All right, you just make a new system and see what happens. So now, if we rewrite, let's do purple. So if we rewrite that square root of negative 1, that's going to become our I, and then we'll get the following. Negative 24 plus I times the square root of 72 divided by, that's fine, 72. Okay, let's keep going. And this just to be consistent. Okay. So then next, let's go ahead and address that square root of 72. Let's simplify that. So we'll do this one. Let's actually go ahead and do this off to the side. Yeah, let's focus on that on the side. So if we look at the square root of 72, that's actually what 9 times 8? So 72 is 9 times 8, right? So that's the same as the square root of 9, and 8 is what? 4 times 2. I wanted to get out as many perfect squares. Let's actually do this a little bit different. What I was doing was going to work, but I'm going to just do a little bit different. So 72 is 9 times 8, and 8 is 2 times 2 times 2. 9 is 3 times 3. So because we're looking for square root, that means we're looking for perfect squares. So we want to group, pull out all of our perfect squares. So that means we're looking for groups of 2. Here's one perfect square right here. Here's another perfect square right there, right? So let's group those together. So then this becomes 2 times 2 is 4. It becomes the square root of 4 times the square root of 9 and times the square root of 2. And let me do these in this color so you know what goes with what. Okay? So now we can simplify those perfect squares. The square root of 4 is 2. The square root of 9 is 3. And that square root of 2, it's not a perfect square, so we just leave it as is, right? So then the square root of 72 ultimately is going to be 6 times the square root of 2. Okay? All right. So that's the green part. So then now let's incorporate that back into our question. So then this is going to become negative 24 plus I, let me see. We got 6 times the square root of 2, so it's going to become 6i times the square root of 2 divided by 72. I think that I is purple, and the 6 is the blue, and this guy was the green one. Okay. So a few more steps. So then, because we're dividing by a monomial, in other words, because we're dividing by one term right here, a monomial is basically one term. We can distribute this monomial into the top, right? So we can do the following. This is going to be the same as negative 24 divided by 72 plus 6 divided by 72 I times the square root of 2. And then, let's see, 24 is what, 8 times 4? So both of those are divisible by 8. Let me show it this way. We're going to divide, basically say this divided by 8 and this divided by 8. Right? They're both divisible by 8. 72 is 9. We can divide both of these by 3. So I'm going to just divide them both by 3. Or factor out the 3's and cancel. So then that becomes what? What is it, 3? So then we get a negative 3 there. That becomes a 9. Plus, that becomes what, a 2? Let me see, how many 3's are in 7? There's 2 and 12 is a 4. So we can take both of these a little bit further. Let's see. Let me just move this down. So yeah, Mr. Kempson, you're actually emailing me as I'm creating the video. You probably see this when you watch the video. Yeah, I'm almost done. So let's see. I'm gonna just keep my colors consistent. So let's see. This 6 was blue. This I was purple. And this guy was green. Again, this was purple. Oh. And this is green. Okay. All right. And so we can actually simplify both of these fractions just a little bit further. That first one becomes a negative 1 by 3. And then both of those are divisible by 2. So that becomes 1 by, or actually we could probably write it as no, sorry. Let's just do it as 1. 1 divided by, what is that, 12? I times the square root of 2. All right. Let's see. This looks okay. And again, just to be consistent, this one was purple and this was green. Okay. So I actually pulled this question. I pulled this example from the viewing example. So you can actually still go back and work yours. I just wanted you to kind of see a live explanation. Go like this, paper. Okay. And I think and I actually have the answer right up above. Negative 1/3, 1 by 12I times the root of 2. Negative 1/3. Yeah, this is fine. Maybe rewrite it. Only change I noticed was like something like this. It's still the same thing. It's just the format is a little bit different. Okay. All right. So hopefully that made sense and you were able to take advantage of that. Let's actually do the following. I'm just being a little OCD. I'm not really OCD, but I think I'm low-key a little bit OCD. Just a little. Like, I'll stop. I don't know. I will stop. It used to be worse, but, And so then it kind of makes me like artsy a little bit as well. But it's neither here nor there. I'm just kind of playing. Anyway. So yeah, so hopefully that made sense and that was able to help. Okay, all right. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your evening. Peace. You.